Hello. Here we are in Advanced Algebra 2. We've got our first set of notes here. We got stuff about, first learning target. We're going to work toward domain and range, as you can probably see by looking ahead a little bit on your notes. Now, you've likely talked about domain and range before, but the format we use, etc., is potentially going to be just a little bit more interesting than what you've seen before in Algebra 1. So, bear with me. Hey, look, we got a first example here. We got to graph this equation. Now, because I was feeling generous, or rather probably I was feeling wordy and I wanted to write a lot, I wrote out all the answers. So, talks about how, hey, you might want to start with some points. You don't know what points to use likely at the beginning. So you just make up some numbers around 0. 0 is a beautiful number to start with. And then, boom, chicka boom, you've got yourself an XY chart. After you've got the XY chart, you throw it down on the grid, you've got yourself a graph with some points, but then you should be thinking something like, hey, that's not everything in life. Those are just the ones I chose. So there's more. So you go ahead and you connect all those points, and then you know they go forever. And so boom, boom, arrows style, you've got yourself a graph. Okay, plotting points, making a graph. Not terribly demanding. But that leads us into this talk about domain and range. So, here we go, domain. Now, domain, it's listed all here for you. You can read it yourself. Domain is the set of inputs. Now, we got this thing called a set notation on how we're going to write domain. So, I can't, speak for what middle school experience you might have had, but if you had Algebra 1 here at Beaverton, probably did not write your sets, your domains, as sets. So you're going to want to pay careful attention here. In the example of that parabola that was just thrown up there, the domain, which is the x values, goes left and right forever, so we say it's all real numbers. Funny story, there's a funny symbol for all real numbers. It's that double back R business. It's awesome. And so then to write the answer, it's x colon x, this funky E thing, and then R. Now, that's not what we actually say. We don't say x colon x funky E thing, because that's insane. So instead we say it's the set of numbers such that, the colon means such that, x is a member of the set of real numbers. That little funky E thing, that is a member of the set. That's what's going on there. Range is the set of y values, or the set of dependent variable values. If you go back and look at that graph from before, the y values started at 0 and went up forever. The arrows had the forever bit going on. So, the range is y such that y is greater than or equal to 0. It started at 0 and hit all the numbers going up. So you can see we've got our little set notation for range. Okay, good times. Now let's do some examples. Example 2, it says graph y equals 0.4x squared, but this time the domain is limited. This is new. The domain is only the numbers between -3 and 3. See, you have the little -3 less than or equal to x, less than or equal to 3. That means the numbers between -3 and 3. So, it's the same table as before, because it's the same equation. So you go back to example 1 and you look at the table. You're like, oh yeah, look at those numbers. I remember them. Good friends. If you want to write them down, you can, or you can just look at them from before, because it's the same thing. Then, go ahead and, dot it up, dot, 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 dot. Boom. Dot action. Okay. That's delightful. But, of course, you're going to remember that, as good as that is, that's not all the dots. Those are all the whole numbers between -3 and 3. Or, all the integers between -3 and 3. But they're not all the numbers. So you go ahead and you connect them, but notice no arrows this time. Because that right there, starting where it starts on the left and ending where it ends on the right, that's the actual graph for this example. Right? This is slightly different from example 1, only because the domain is limited. So you might need to go back and forth and look at them just to make sure you're seeing what's different there. Okay, next example. hey, y equals 0.4x squared. I've seen this before, you say. Yes, you have, I say. But the domain this time is, whoa, that's different. It says -3, 1, 2, 3. Not some sort of rule for greater than a number or less than a number or both, like last time, but rather just those 4 numbers. So, table of values, x, y, boom, boom, boom. X, Y chart, but notice just those numbers. You might miss your other friends, -2 and -1 and 0, and maybe you had some extended friends at 4 and 5, but they just don't count for this problem, I'm afraid. So, XY chart from there, they make dots, and boom, that's your graph. That is an incredibly uninteresting graph, but that's the answer to the question. You had to graph that rule only for that domain. All right, let's move on. Boom, graph y equals absolute value of x minus 2, and then the domain is from -1 to 5. Now, I'm going to say that again. The domain is all the x's such that -1 is less than or equal to x less than 5. So that's all the numbers between -1 and 5. But notice x gets to be -1 when it's feeling down. It does not get to go all the way up to 5. But still, we'll go ahead and make ourselves a little xy chart. Throw down all those integer x's between -1 and 5. Now, obviously, if it was a much wider band, you'd probably have to get smart about making some special choices. But, -1 to 5, it's not that many numbers. 7 numbers. Okay, boom, boom, got your x's down. Plug them each in. Remember, this one is absolute value. So you got to, subtract 2 and then decide, hey, how do I make this look positive? Because that's what absolute value does. So, yeah, a little note here saying that 5 isn't really part of the domain, but it's going to be useful. You'll see what's going on later. Okay, the y values, like I was saying, you plug them in, you subtract 2, then you do absolute value and go, woohoo, look at that. Okay, there, you've got yourself some points. Boom, 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 boom. Now remember, this is supposed to be all the numbers between -1 and 5. So, well, not just those points. It's all the numbers. So go ahead and connect them up. Boom, boom, shoom. Now, this looks like it should be the answer. I should have used a straight edge, but it's actually impossible on the iPad screen. So I apologize that it's not all straight edge and beautiful. Okay, this looks like the answer, but look at that 5. X isn't really supposed to get to 5. On the graph, X goes all the way up to 5. Here's how you fix it. Erase that 5 business and make it an open circle, and then make the graph go to an open circle. That right there, that's the graph where you're starting at -1, you're going up to, but not quite up there, on 5. All right, here's another one. Now it's less work to do, more pretty picture style. You're going to write the domain and the range of these graphs. Okay, so first of all, we're going to do the domain. The domain starts at -2 and goes to 2. I drew a little red line there to help you see what's going on. So that means it's x such that -2 less than or equal to x less than or equal to 2. Boom to boom, -2 to 2. All right. Now range. Range is the y's, or rather the y values that are hit. You can see it goes down to -3, up to 3. So it's y such that -3 less than or equal to y less than or equal to 3. All right. This one, it's meant to get you started. You want to keep this for looking at later. But the more examples you have, the better. Hey, look at that! Another example. Okay, so example 6. Write the domain and range of the graph. Now, here's what's going on. Domain. Domain's the x's. Starts at -4, goes to 8. X such that -4 less than or equal to x. Ooh, wait, doesn't actually go to 8, goes super duper duper close to 8. goes as close as you can imagine. Actually, closer than that. Close. It's actually not a funny joke. Okay, so -4 less than or equal to x less than 8. Because it goes up to 8. That open dot, that circle that's not filled in at 8, tells you that's going on. Now for the range, here's a funny thing. It's supposed to be all the y values. But I made this all super sneaky style, where the only y value that's hit is the number 2. So it's just the number 2 in a set. Hey, that's pretty much it. We've got an assignment here, but to be honest, that's what class time is for next time. So thanks for watching. Bring your completed notes to class, please. And look forward to hearing what your questions are as we move forward. Have a good day.